بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. This is section 8.2, area of a surface of revolution. Well, we studied in chapter 6, section 6.2 and 6.3, the volume of solid of revolution. And uh, we would like to study here the surface area or the area of the surface of revolution. So let us start by talking about the surface area of a cylinder. If we have a cylinder like this, then the surface area is given by the equation A equals 2 pi RH, uh, where 2 pi r is the area of the base. And if you multiply the area of the base by h, then you get the area of the surface of the cylinder. You can imagine that we have a cut here, and then this is the surface of the cylinder without the bottom and the top. And the area of this rectangle is just 2 pi RH. So this is what we mean by surface area. So if we have a curve given by a function y equals f of x, and we rotate or revolve this curve about the x-axis, then we obtain this shape, or this shape in R3, and or let us call it surface of revolution. And we want to find the area of the surface. Okay, the area of the surface of revolution. To find the area of the surface from outside, let us divide this area, the surface area, into portions, and let us find the area of this portion. If we know the area of the surface, or the surface area of this portion, then we can divide the surface area into n portions, and when we take n to infinity and find the limit sum, so the integral of the surface area of this portion would give the surface area, all the surface area. So if you look to this portion to find the surface area, similar to the idea of the cylinder, uh, the area of this circle, what would be the area of the circle, the outer circle here? Uh, if the radius is y, look, this is the radius, the dashed line, the radius. If the radius is y, then we need the length of this portion. Well, this is in fact the circumference of the circle. So the circumference of the circle, also here, 2 pi r is not the area of the base. Sorry, it is the circumference, of the base, which is a circle. So the circumference of a circle is 2 pi r. So the circumference of the circle here is 2 pi r times this portion. And this portion, which represents the height here, is in fact an arc length. So you can say that the surface area of this band is 2 pi times y times ds, the arc length, if we call the arc length ds. If you want to know more about ds, please look to section 4.1 first. Watch section 4.1, or sorry, 8.1. So if we want to find the surface area, then it would be the integral of 2 pi y ds, where y is the distance from the surface of revolution to the axis of rotation, or it is the radius of the circle. So that's the formula. The surface area, okay, of the surface obtained by rotating this curve about the x-axis is given by this equation. So notice we are rotating about the x-axis. So when we rotate about the x-axis, the radius is given by y as we have seen, okay? And ds is the arc length. And also we have seen ds in section 8.1. It can be written in terms of x or y. This is ds from section 8.1, square root of 1 plus dy by dx squared dx, or dx by dy squared dy. So the integration could be with respect to y, and then here we have dx by dy, and here we have x is written as function of y, g of y, or f of y, while here the integration would be with respect to x, and we have dy by dx, and the function here has to be y has to be a function of x. Here x is a function of y, here y is a function of x. So when we rotate the surface or the curve about the y-axis, the radius will be x, not y. Okay, when we rotate about, see, about the x-axis, about the y-axis, so the radius of the circle would be x, not y. So that's the most important thing to remember. When we rotate about the x-axis, the radius is y. When we rotate about the y-axis, the radius is x. So the circumference here is 2 pi x, while here is 2 pi y, and the surface area would be either integral 2 pi y ds or integral 2 pi x ds. So that's it. This is the formula. Rotation about x-axis, integral 2 by y ds, about y-axis 2 by x ds. Let us find or solve some exercises. We have this curve from -1 to 1. Now, which means in fact that in each case, here, whether rotation about x-axis or y-axis, I have two integration. I can integrate with respect to x or integrate with respect to y. So what to do in the exercises? Well, in the exercises, if he says x is given from -1 to 1, then I will just uh, find the integral with respect to x because the limits are given. So this is the curve, and x is from -1 to 1. Find the area of the surface, and please pay attention to the difference between section 6.1, where we find the area between two curves, and here the area of the surface of revolution. So watch or look to this word carefully, area of the surface obtained by rotating this function or this arc about the x-axis. If we are rotating about the x-axis, then I immediately write that s is 2 pi y ds. And since the limits of x are given, so I will write from -1 to 1, 2 pi y, and ds, I will write the formula of ds 1 plus dy by dx all square dx. So I will use the integral with respect to x. Well, now this is y, and the integral would be with respect to x. So I can't really leave it y. I have to write it. We know that y is a function of x. So you can either write it y or you write it f of x. Since the integral is with respect to x, I will write it f of x. If the integral is with respect to y, I will just write it y. So it would be integral from -1 to 1 2 pi, and y is square root of 4 minus x squared times 1 plus y prime, or dy by dx squared dx. And let us find here what is y prime squared. So y prime is a derivative of the square root 1 over 2 times the square root times the derivative of the radicand, which is negative 2x. 2 cancels with 2, and y prime square would be, if you raise it to the power 2, the negative will be positive, and I have x squared over 4 minus x squared. Now 1 plus y prime square, similar to what we did in section 8.1. We are just evaluating the arc length. So it's 1 plus x squared over 4 minus x squared. And to add these two terms, we have 4 minus x squared plus x squared. X squared cancels with x squared, and the sum would be this. So now this would be integral from -1 to 1 to pi square root of 4 minus x squared, and times the square root of this. Well, I can write the square root, distribute the square roots. So square root of 4 would be 2, and the square root of 4 minus x squared dx. And now this square root cancels with this square root, and I have 2 times 2, 4 pi, times 1 minus minus 1, or plus 1. So the answer is 8 pi. The surface area is given by 8 pi. Another question. The portion of the curve x equals between y0 and y3. So the limits with respect to y here are given, is rotated about the x-axis, and the question is the area of the resulting surface. So S, the surface area, is integral of 2 pi. We are rotating about the x-axis, so it is the radius is y, 2 pi y ds. But here the limits are given, the limits of y. So I will write ds in terms of y. So I will use the integral in terms of y, and I write here from 0 to 3, 2 pi y, and ds is, by definition, if the integral is with respect to y, then I have dx by dy square here. Now this is y, and this is y, so good. I'm not going to write y as a function of x. Notice that here, since I'm using integral with respect to y, then the problem has to be given like this. I have to have x as a function of y, which is the case. So good. I need to find x prime, or dx by dy. So x prime is, find the derivative of x. So it's 2 over 3 times 3 over 2 y to the power half. And the product is just 1 here. So x prime square would be y to the power half to the power 2, which is y. So this would be integral from 0 to 3, 2 pi y times square root of 1 plus x prime square. So it's 1 plus y square. No, x prime square is y. Yeah, there is no square. This is x prime square, so 1 plus x prime square would be just 1 plus y. All right, dy. That's it. And we need to solve this integral. We find this integral. Well, to solve this integral, I will solve it by usual substitution. I will take u equals 1 plus y. Then du would be dy. And if y is 0, u would be 1. U is 1 plus 0. And if y is 3, u would be 1 plus 3, 4. So this would be integral from 1 to 4, 2 pi. Y from here is u minus 1 times square root of 1 plus y is u, dy is du, and this is a very easy integral now. You write it 1 to 4, 2 pi, you can take the 2 pi out. U to the power 1 times u to the power half would be u to the power 1 plus half, which is 3 over 2, minus u to the power half du. Then it would be u to the power 3 over 2 plus 1, which is 5 over 2, minus u to the power 3 over 2 times 2 over 3 from 1 to 4, and you find the answer. The third example, the arc of the parabola y equals x squared from 1, 1 to 2, 4 is rotated about the y-axis. Find the area of the resulting surface. Well, area of the surface when we rotate about the y-axis is given by integral 2 pi y-axis, so this is x ds. Notice here that he said from 1, 1 to 2, 4. So he didn't say x between or y between, he gave me both. So I can really solve this question in both methods, in two methods, using the two definitions. So first, I will let me find the integral with respect to x. So with respect to x, ds would be written as 1 plus dy by dx square. And in this case, I need y to be written as a function of x, which is the case. So the integral would be from, of course, x also here is 1 to 2, so x from 1 to 2. So integral from 1 to 2, 2 pi x, and let us find y prime. Y prime is 2x, so 1 plus y prime square would be 4x square dx. And this would be the surface area. To solve this integral, I can take u equals 1 plus 4x square, usual substitution. And here I have 2 pi x, so I will have 1 over 4, and 2 times 4, 8x dx would be du, and square root of u. And if x is 1, then u is 1 plus 4, that's 5. And if x is 2, 2 square, 4 times 4, 16, then u is 17. And this would be the integral from 5 to 17. And it is easy to find this integral. Well, I have pi over 4 outside. And this is u to the power half, so it would be u to the power 3 over 2 times 2 over 3 from 5 to 17. And I can find 17 to the power 3 over 2 or 1.5 minus 5 to the power 3 over 2 or 1.5. And I can multiply, it would be approximate, so it would be pi over 6. Okay, that's the actual answer. Pi over 6 times 17 to the power 1.5 minus 5 to the power 1.5. Okay, But if you uh, find an approximate solution, you will get approximately, uh, let us say, times pi. Yeah, approximately the answer is 30.85. So that's the surface area. Now we can solve the problem in another way, finding or using the integral from with respect to x. So it would be 2 pi x integral. Instead of writing 1 plus dy by dx, I write it dx by dy, and the integral would be with respect to y. And the y will run from 1 to 4. So y from 1 to 4. And here x has to be written as a function of y. So actually he said y equals x squared. So I have to solve it for x. So x could be plus or minus square root of y. But x is positive, it's from 1 to 2. So I'll choose the positive sign. So x prime or dx by dy would be 1 over 2 square root of y, and x prime square would be 1 over 4y. And 1 plus x prime square would be 1 plus 1 over 4y. And if you add these two, you get 4y plus 1 over 4y. And notice that this is x, and the integral is with respect to y. So I will change it in terms of y. So x is g of y, x is square root of y. Either you use x or square root of y. I used x when the integral was with respect to x, but now I cannot use x. I have to use a square root of y because the integral is with respect to y. And now square root of 1 plus x prime square is the square root of 4y plus 1 over the square root of 4y. Square root of 4 is 2 times the square root of y dy. 2 cancels with 2, square root of y cancels with square root of y, and the integral of 4y plus 1, this is a linear function, so pi comes out, and 4y plus 1, I raise it to the power half plus 1, which is 3 over 2 times 2 over 3 from 1 to 4. And now this would be 2 pi over 3 times 4 times 4, 16 plus 1, 17 to the power 1.5 minus 1 times 4, 4 plus 1, 5 to the power 1.5. So the difference here is this is pi over 6 and this is 2 pi over 3. Yeah, here when I find the integral of 4y plus 1, it should be 4y plus 1 to the power 3 over 2 times 2 over 3 times, in fact, times what? 1 over 4. I have to divide by 4, the derivative of 4y plus 1. So when I divide by 4, then 2 cancels with 4, and I have pi over 6 times 17 to the power 1.5 minus 5 to the power 1.5. And this is exactly the same answer here. So this proves that you can solve the surface area using any of the two methods. But sometimes one of the methods is very difficult. Sometimes it's not possible. Maybe you cannot solve x in terms of y, or the integral is very hard. So this is what we are going to do usually. Whenever the question is given with the limits of x are given, we will use dx. Set up an integral for the area. So he doesn't need the evaluation of the integral, just set up an integral for the area of the surface. generated by rotating this curve y equals ex, x from 0 to 1 about the x-axis. Well, about the x-axis, immediately I can say that s equals integral 2 pi x-axis, so y ds. And x here is given from 0 to 1, so ds will be written in terms of dx. So I'll have here dy by dx squared, and I need in this case y to be a function of x, and it is already given as a function of x. So y prime is ex. Good. Now 2 pi. Now y, I cannot leave it as y. I have to write it as a function of x. I have to write it as f of x in this case, because the integral is with respect to x. So y equals ex. So I just write y as ex. And I have square root of 1 plus y prime square ex to the power 2 is just e to the power 2x dx. And this is the integral. Here, the given curve is rotated about the x-axis. Set up, but do not evaluate, an integral for the area of the resulting surface by integrating with respect to x-axis first, and then with respect to the y-axis. I mean to x, to the variable x, and here to the variable y. So A, the most important thing for me is the rotation. The rotation is about the x-axis. So if the rotation is about the x-axis, then the surface area is given by 2 pi y ds. And in part A, he asked me the integral. He asked me that the integral would be with respect to x. So ds will be replaced by in terms of dx. So I have 1 plus dy by dx to the power 2. Now I need, of course, y here has to be written as a function of x, which is the case. Y is cube root of x. So y prime is, this is x to the power 1 over 3. So y prime is 1 over 3, x to the power 1 over 3 minus 1, or negative 2 over 3. So y prime square would be 1 over 9, x to the power negative 2 over 3 times 2, so x to the power negative 4 over 3. When you raise to the power 2, you multiply the powers. So he just needs a setup of the integral. He doesn't ask for evaluation. So the answer would be x from 1 to 8. I cannot leave it as y. I have to write it as a function of x. So I write cube root of x times square root of 1 plus y prime square is 1 over 9, x to the power 4 over 3 if I take it down below, times dx. So that's the required integral. I don't have to simplify because he just asked for the integral, to see the integral. So this is part A. Well, part B, in part B, he needs the integral to be with respect to y. So the integral would be 2 pi y as usual, but ds here would be in terms of y dy. So I have 1 plus dx by dy square. I need to understand y from where to where, runs from where to where. So let us here, come here. This is the relation between yx If x is 1, I can replace x by 1 here. Cube root of 1 is 1. So if x is 1, y is 1. If x is 8, cube root of 8 is 2. So y runs from 1 to 2. Now in this case, this is y and this is y, so I'm not going to write it as a function of x. Actually, in this case, I need x to be written as function of y to find dx by dy. So when I raise both sides to the power 3, then x would be y to the power 3. Because this is x to the power 1 over 3, raise it to the power 3. So x prime or dy by dx would be 3y squared. So this integral would be from 1 to 2, 2 pi y times square root of 1 plus square of this, which is 9y to the power 4 dy. And this is the integral of s with respect to y. You can use your calculator to evaluate this integral and this integral, and they must give you the same answer. Another question where y here, the limits of y are given, but he asked me to solve first integration with respect to x. And remember, the rotation is about the x-axis, and this is what is important in the surface area. If the rotation is about the x-axis, then 2 pi y ds. And I can write ds as integration with respect to x, like this. And now I need to find x from where to where. So again, this is the relation between x and y. If y is 0, zero plus 1, len 1, that's 0. If y is 1, 2 plus 1, 3, then x is len 3. So the integral would be from 0 to len 3. And y here has to be written as a function of x. So I need to solve this equation for y. So let us start from the equation itself. X equals len 2y plus 1. If I raise both sides to the base e cancels with len, and I'll have 2y plus 1 equals e to the power x. So y would be -1 plus e to the power x over 2. And now y prime would be derivative of -1 is 0, it would be ex over 2. 2 is a number, just leave it. Find the derivative of -1 plus ex, which is ex. So the integral would be from 0 to len 3, 2 pi, y here also, I cannot leave it, I have to write it as a function of x. So -1 plus e to the power x over 2, this is y, times the square root of 1 plus, and find y prime square, which is e to the power 2x over 4 dx. And this is the surface area given in terms of x. Now part B, he asked now that the integral would be with respect to y. So y is from 0 to 1, and I have 2 pi y times square root of 1 plus, I write it now dx by dy square dy. Well, this is y, this is dy, that's okay. And here x has to be written as a function of y, which is as given in the question. So I need to find x prime 1 over 2y plus 1 times the derivative of 2y plus 1, which is 2. I cannot cancel 2 with 2. So the answer would be from 0 to 1, 2 pi y times square root of 1 plus x prime square, which is 4 over 2y plus 1 to the power 2 dy. Again, if you find the integral of these two using the calculator, you should get the same answer. Here, the given curve is rotated about the y-axis. Set up but do not evaluate an integral for the area of the resulting surface by integrating with respect to x and with respect to y. So let us first integrate with respect to x. The most important thing here, the rotation is about the y-axis. So s is integral 2 pi x ds. And now, to have the integral with respect to x, then I will write ds as 1 plus, I need dx here. So dy plus dx to the power 2. And I need y to be a function of x. Well, x times y is 4, so if I solve it for y, dividing by x, I will have 4 over x. So y prime would be negative 4 over x squared. And now I can write the integral as it is dx and x from 1 to 8. This is x and this is dx, so that's good. Square root of 1 plus y prime square. If you raise this to the power 2, it's 16 over x to the power 4 dx. And that's the integral. Or, not or, part B here. Part B, he said, now I need the integral with respect to y. So S would be integral 2 pi x as usual. It should be x because the rotation is about the y-axis. But the difference would be 1 plus ds will be written in terms of y. And here I need dx by dy this time to the power 2. And I need x here to be written as a function of y. So if I solve this equation for x, I divide by y, and x would be 4 over y. And x prime would be negative 4 over y squared. So x here is not good because the integral is with respect to y. So I write it as 4 over y because x is 4 over y. And dx by dy squared, so this is 16 over y to the power 4. And the only missing thing now is to write the limits of the integral. Well, here I can solve the equation for y. We said it is 4 over x. So if x is 1, y is 4 over 1, which is 4. And if x is 8, y is 4 over 8, which is half. And here I write the smallest value of y here and the largest here. So it would be the integral from half to 4. Pay attention to this. I don't write. Usually in substitution, we replace 1 by 4, so we write it from 4 to half, but this will result in a negative surface area. So in the surface area, when we have this case, we keep the smaller number below, so half to 4. Now, if you use your calculator, you should find the same answer in both parts. The last question for today would be question 7, and I'll continue the other questions in another video. So here, same, the rotation is about the y-axis, and he needs to write both cases, about x and about y. Integration with respect to x and with respect to y. The most important thing for me, the rotation is about the y-axis, so the formula is 2 pi x ds. And then I can write ds in terms of x or y as I like. So in the first part, I write ds in terms of dx. So I should have 1 plus dy by dx to the power 2. Let me take dx out of the root. In this case, y has to be written as a function of x. Well, it is written, so that's good. So y prime, the derivative of this is cosine x. And this is x and this is dx. Everything is nice here. And even the limits are given with respect to x. So 2 pi x square root of 1 plus y prime square is cosine square x dx. So the first part is very easy. Now, if we want to write the integral with respect to y, then I have 2 pi x as in the first part, but dx by dy, this is the change, this is the difference. And the integral here will be with respect to y. And in this case, the function should be written in terms of x. So I need to solve this equation for x. So y minus 1 equals sine x, and then x is sine inverse y minus 1. And x prime would be the integral, the derivative of sine inverse is 1 over square root of 1 minus whatever inside sine inverse squared times the derivative of it, but the derivative is 1. So s would be equal to 2 pi. Also, this is x and this is y. So I have to write x in terms of y. So it's sine inverse y minus 1 times the square root of 1 plus, and now the derivative is squared, so it's 1 over 1 minus y minus 1 squared. And finally, I need to find the limits with respect to y. So here, if x is 0, sine 0 is 0, so y would be 1. And if x is pi over 2, sine pi over 2 is 1. So 1 plus 1 is 2. So y runs from 1 to 2. Please check that these two integrals will give you the same answer. I hope you understand now the formula how to evaluate the surface area.